Hey everybody, Tommy Clayton, middle school OpenSciEd teacher and lesson writer, here to share lesson 12. So this is the one that wraps it all up for our unit Forces at a Distance. It's really cool assessment. Has a really wide open range of things that kids can do on it. And I think there's some really cool opportunities to do some really different things with that assessment. So let's dig in. Let's find out a little bit more about that. So in this video, we're going to talk a little bit more about how we got here. We're going to take a look at this lesson at a glance, see some of the key moments in this lesson, and hear a little bit about some tips and tricks and some material management. So let's remind ourselves how we got here. So in lesson 11, we figured out a lot about the forces between magnets or an electromagnet and another magnet in terms of the different factors that can affect those forces, the strength of those forces. And so in this lesson, we really want to put it all together. So what are the cause and effect relationships that can explain how magnetic forces at a distance make things work, right? How can we explain all these different things that we've been looking at, including the speaker? So let's take a look at this lesson at a glance. This is a putting the pieces together lesson. It's going to take about 2 days. It'll be about 20 minutes in preparation. There's no hands-on investigation, and students are not required to have devices. So this lesson breaks out into a couple of different chunks. So that first chunk is going to be most of the first day, and it's going to carry over a little bit into that second day. And then we are in that second day going to have our last chunk, which is really where we focus on that assessment. So in this first day, we're going to really put it all together and explain our original phenomena and some other related phenomena. And then in the second day, we're going to use what we figured out to invent something new. Pretty cool stuff. So we figured out in the first day, really, we're putting it all together that forces transfer energy into and out of magnetic fields. The amount of that energy stored in that field depends on the strength of the forces, which are affected by several factors. We figured out a lot about those factors in lessons 10 and 11. And so there's all sorts of different phenomena that involve the strength increasing, and that can have more than one cause. On day 2, we really figure out how we can apply all these ideas to solve a problem by sort of coming up with an invention. So let's take a look at a couple of key moments. So in part 1, we're going to review a cause and effect chain that we did for home learning from the previous lesson. So we're really trying to put everything together about the speaker. And so we're going to compare some chains with a partner, and then we're going to update that class cause and effect tracker that we've been doing. Super important because we're going to use that later on for our assessment. Then in part 2, we're going to return to the speaker. We're going to add some new ideas about what we figured out in terms of lesson 11 and 12 about, the number of coils or the magnet being really big or them being really close together. And we're also going to apply this stuff to explain how a maglev train works, right? Or a junkyard train or electric cars. Thinking about all these different variables that we now know and how those relate to, being able to move a train really super fast. And so ultimately, the big punchline here is that it's not just one thing. There's lots of different causes that result in the effect of those forces being really strong. So it might be lots of coils and a really big magnet, right? Or it might be lots of voltage and lots of coils, something like that. Okay, so in part 5, this is the last part of the lesson, and that's where we're going to demonstrate understanding. So after we had that scientist circle, we return back to our driving question board. We do a little bit of celebrating and reflecting, and then we dig in this last part to demonstrate understanding. So we're going to brainstorm some ideas for an invention that could use an electromagnet to solve a problem or do something. Then we're going to pick one, and that's ultimately what we're going to talk about on the assessment. So we're going to show how it works, do some modeling, and design an investigation. And we'll dig more into this in a second. So really, this is the end of the unit. There's some options to extend the learning. If you have some time or you have some kids with high interest, you could return to the homemade speaker at the beginning of the unit and give chance for students to apply some of what they've figured out about those variables to see if they can make the speaker louder or clearer. You could use this assessment that we're going to dig into for a larger project, kind of do some sort of like Shark Tank thing or, invention sort of convention. And in lessons 9, 11, and 12, there's some extension readings and simulations. You could also return to those, investigate those. They help kids dig in more to electricity, some things about Earth's magnetic field, learning more about microphones. There's some really cool stuff in there. So that might be really helpful to extend the learning. Or if you're finding that kids had some ideas on the question board that were not necessarily answered, those readings might help to serve as answers for those students who are wondering more about things like microphones or Earth's magnetic field, so on and so forth. Okay, so let's talk a little bit about some tips and tricks. Primarily, we want to really dig into this assessment and unpack it a little bit. So in part 5, when they're looking at this assessment, the first thing they're going to do before they even get the assessment is, as a class, brainstorm ideas for an invention. It doesn't have to be a real thing. We're not going to make it. Just we're having some fun here with something that could help them in their everyday life. So maybe it's an automatic door closer. Maybe it's some type of like special magnet that can help them do something, right? The idea is we want it to include an electromagnet. So if kids are struggling to think about an application, try to help them think about like, well, when would you want a magnet to be able to turn on or off? When would we want to vary the strength? Or when would we want a reverse direction? When might we need a push or a pull? Or where we need a pattern to change, right? Maybe we want to send a message of some kind. The big idea here is push students to think about how they could use an electromagnet and not just something like a refrigerator magnet or a magnet that can hold something up, right? We really want to think about the ability to control that magnetic field. So questions 1 and 3 are really going to help students to focus in on what the invention is, right? So they're going to explain what it is. They're going to model how it works. And again, we're not looking for them to actually make something. It doesn't have to be totally realistic. What they're modeling here is the forces and the magnetic fields, okay? So you can support them by calling back to that doorbell assessment and really helping them to focus on, showing those forces. Is the object turning on and off? Is it flipping poles? Are we getting pushes and pulls? Help them to focus on those things. Then in question 3, they're going to develop a cause and effect chain. So support them by returning back to that class list to help them use that to think about the cause and effect chain for their particular invention. Questions 4 and 5 are now more about the work that we did in 10 and 11. So here's where we're going to look at some cause and effect in terms of changing some of the variables in our design. So it's going to ask students to design an investigation to test that possible variable change. So here, again, a lot of this is hypothetical, but the idea is we're calling back to that work that we did in 10 and 11. How could they design an experiment? Remind them of what we did in lessons 10 and 11, how they collected the data, and then they're going to make predictions about what they might see. So that work that we do in 10 and 11 is going to be super important to call back for questions 4 and 5. Okay, no new words here in this lesson. And the only poster that we have to deal with is that cause and effect tracker that we've been really building across all of the lessons. So that's going to do it. That is Forces at a Distance. I hope you enjoyed this video series and you found some great tips and tricks in here. This is a unit that my students really loved, and particularly these last couple of lessons when they were able to really try investigating some things on their own and try some different variables. And students really enjoyed coming up with these inventions. And sharing them out and coming up with some ideas after the assessment. So hopefully if you have a day or two to add to it, that would be awesome. But we also know that time is precious. Thanks for watching, and we'll see you in the next unit.